Question number 17. When a sound wave travels from a region of hot air to a cold air, it refracts as shown. Okay. So what changes occurs in the frequency and wavelength of the sound? See, it appears like a refraction, but the problem is whether to find out whether it's a what to call it, a rarer medium to denser medium or denser to rarer. Only then you can say anything about this, right? So what you do is first is whenever you have a ray of light like this, ray of sound wave like this, first you draw the normal. When you draw the normal like this, what do you understand from here? Drawing the normal, okay, it's like this over here. So this is your angle of incidence and this is your angle of refraction. Now you see, definitely I is greater than R. Keep a protractor or just by visible only, you can say that this I is greater than R over here. When I is greater than R, what can you conclude now? This is your rarer medium, this is your denser medium. When this is your rarer medium, let us say this velocity of sound wave here is C, velocity here is V, definitely C is greater than V. Now we know that frequency will not change in either of the medium. In reflection, refraction, frequency will not change, okay, except in Doppler effect, no other frequency changes. So therefore, so I can now write F into lambda is C, lambda 1, and this should be F into lambda 2, right? So now this F and F cancels over here. What do you get? Lambda 1 should be greater than lambda 2. That means here it is lambda 1, here it is lambda 2. Lambda 1 should be greater than lambda 2. Now let us look at the answer. So frequency remains unchanged, so any one of them should be the right. And here frequency, what happens? In the rarer medium, it is larger. In the denser medium, it is lesser. What changes occur in the frequency and wavelength of the sound as it passes from the hot air to the cold air? What happens? The wavelength decreases. So answer is B over here.